All right, you are welcome again. Today, let's talk about relativity in physics. And then let's take a look at this question. A square of area 100 cm squared is at rest in the reference frame of observer O. Observer O prime moves relative to observer O at 0.8 c and parallel to one side of the square. What does observer O prime measure from the area? So here, this question is practically telling us that there are two observers. The first observer is at rest and the second observer is in motion. So the first observer observes a square and the area of that square is 100 cm squared. And then here they are asking us that the observer in motion is going in the velocity of 0.8 c. And then we are asked to give the measure of that same area by the observer in motion. Hello. And then you are talking about that this observer in motion is parallel to one side of the square. You get it right? So the effect of the measure is going to affect one side of the square. You get it right? Good. Now let's go. This square is in two dimensions. We have the length in the x-axis and the length in the y-axis. So here we are talking about one side of the area. So that means we're only going to consider one axis. Okay, now let's consider the x-axis. Now if we consider the x-axis, that means the y-axis remains the same. Okay, good. Now the length observed by the observer at rest, let's call it Lx, okay, or L subscript x, and then the length observed by the observer in motion, let's call it L prime subscript x. Okay, good. Now the length observed by the observer in motion is going to give us the length observed by the observer at rest times square root of 1 minus v squared all over c squared in bracket. Okay, good. And then here now we discover that the area observed by the observer at rest is 100 cm squared, length times breadth, right? Good. So that means that this particular length is 10 cm. Okay, one side of it is 10 cm, the other side that is unseen is 10 cm. It's correct. Good. Now the length, which is L subscript x, here gives us 10 cm. So let's write 10 multiplied by the square root of 1 minus, now the v, which is the velocity, is 0.8 c. Now we'll put it in bracket squared all over c squared. Okay, so this 0.8 c squared, let's distribute the squared. Okay, that means we're going to have 0.8 squared times c squared all over c squared. So c squared in numerator will cancel c squared in the denominator, right? Good. We'll be left with 1 minus 0.8 squared. So when you say 0.8 squared, it's going to give you 0.64. So here we have 10 multiplied by square root of 1 minus 0.64. When you say 1 minus 0.64, it's going to give you 0.36. And then the square root of 0.36 is going to give you 0.6. Then 10 times 0.6 is going to give you 6 cm. All right. So the length measured by the observer in motion is 6 cm. it is parallel to one side. That means going to only see one side. Okay, so the side that he measured, that he sees and he measured, is given as 6 cm. Okay, so now the area measured by the observer in motion is going to give you, now let's call it A prime, right? Good. This is going to give you the length in x-axis measured by the observer in motion times the length in y-axis measured by the observer in motion. Okay, now let's use L prime subscript x and then L prime subscript y. You get it, right? Good. Now, because it is parallel to this observer in motion, that means it's only one side going to see, and there's only one side that is affected. All right? Good. Now, that means we're going to say that the area measured by the observer in motion, which is A prime, is going to give you the length, which is contracted, which is 6 cm, times the other length, which is 10 cm. So 6 times 10 is going to give us 60 cm squared. So a square is measured by an observer at rest, and it gives the area of 100 cm squared. Then another observer is in motion, and then you discover that this man is in motion with a velocity of 0.8 c parallel to one side. Is going to take the area measure of that same square to be 60 cm squared. All right? Yes. So the observer in motion and the observer at rest, they measures differently because of the different frame of reference. All right? Yes. Thank you very much. Let's take another example.